Alright, my name is Hai Lee, and this is Physics Lab 1 Charge Tapes. So, for the introduction, the purpose of this lab is to create charge samples using tape. We can do this by observing the interactions between the charge pieces, and we can conduct another experiment to estimate how much charge is in one of the charge tapes and whether or not there's a deficiency or a surplus. The fundamental physical principles that we're going to use are Coulomb's law to approximate the charge tapes as point charges, and we can use this law to determine if they're being attractive or not. And the second is Newton's second law involving net force. Since the net force for the floating tape will be 0, we can set the gravitational force equal to the electric field force. And for the initial measurements, my tape mass was 0.000205 kilograms, and my length was 20 centimeters. The distance for the floating tape on the top right ended up being 26.9 centimeters, and the gravitational force and electric force ended up being equal. And these were the charges on the tape and how many electrons the tape was deficient by. So for the experimental model, for the first experiment, which included 2 interacting U-tapes, it involved pulling taping 2 U-tapes onto a table and pulling off the top one. And this would test whether the charges had been polarized on the tape. For the second experiment, we had one tape on top of 2 books or 2 pillars, and we had another U-tape go under it to try to push the 2 tapes apart until the 2 tapes reached, until the top tape would reach a net force of 0, where the electric force from the bottom U-tape would cancel out the gravitational force from the gravitational force of the top U-tape. And this was using Coulomb's law and Newton's second law. For the systems and surroundings, the system included tape A and B, and the surroundings was pretty much everything else, like the table, the books, my hand. And some observations and expectations that we had for the first experiment was that we expected the 2 U-tapes to repel each other, which did happen because they are charged with the same type of charge. And when a U-tape gets close to a neutral object, like my hand for example, it will start attracting towards it. And it should attract to a negatively charged plastic pen because if the U-tape is positively charged. For the floating U-tape, when the momentum of tape B isn't changing, we can conclude that the net force is 0 due to Newton's law. And the vertical forces on tape B should only be the electric force from tape A and the gravitational force on tape B. And some assumptions that we made are that the U-tape has both U-tapes have the same net charge due to them being on the same roll of tape. And we treated each tape as if they were on a single point charge because it just makes it more simpler and there's symmetry. Some possible errors are my hand could have mishandled the tape, my room could have been humid, and it was kind of difficult to measure the distance between the floating tape and the non-floating tape. So here's the code. It's pretty self-explanatory. I had my results here. It's in comments, but here's a model of it with the electric force going up and gravitational force going down. Some more questions are, if protons and electrons switched, nothing would change except like the signs. And it's important to handle the charge tapes as little as possible to prevent any charges from transferring in the wrong way. And the conclusion is that we explored charge interactions using U-tapes, and we observed how charges and tapes interact with each other. And we also emphasized the need to not mishandle the tapes. And we gained practical insight into the electrostatic forces through real-world examples.